Hi, welcome to the demonstration corner. My name is Kelsey. I'm the lab lead here at Thermtest. And today we're going to be going through a quick demonstration of the iTPS feature with our MPV, which is the Intelligent Transient Plane Source. So the Transient Plane Source method is a rather popular method used to test a variety of different materials for different thermophysical properties in compliance with ISO 22007-2. So from pages 8 to 12 of ISO 22007-2, there are a series of rather complex steps required to select for appropriate sensor size, test time, power, calculation window, etc. So we have developed a new technology that automates that process to select all these parameters for you in accordance with the ISO with minimal user input. So we'll just come in a little bit closer and we'll get started with the demonstration. So I have a few different samples here set up, all with very different conductivities, different shapes, and different sizes, along with different sensor sizes that would go along with them. So it can be quite daunting to select the appropriate sensor size along with the correct parameters for each sample. So to get started with the iTPS, we just need to first pick our sample. So we're going to use these small Pyrex samples. So all we have to do is measure the radius and the height. And then we can go over to the software and it will tell us which sensor we should use based on these dimensions. So first we'll just go through the steps of setting up a measurement with our software. So on this general page we'll have to enter general information, so operator ID, the method we'll be using. So we're going to be using the Transient Plane Source 3D disk source method. And then we need to select a location to save the test file. Then we can hit next. So on the devices page, we just see what instrument we're using. So we're using our measurement platform, Versatile, at room temperature. And then we can go to our sample page. So here's where we're going to enter the information relevant to our sample. So we're testing Pyrex, and we'll enter the height and the radius that we measured previously. We'll select the port that our connector is connected to. And then here with this little light bulb, using these dimensions that we entered before, the software is automatically going to recommend the appropriate sensor to use. So I'll just jump right back over to our sample setup and get that all connected using that sensor. So we'll just take our 2117-1 sensor and connect to our TPS adapter, aligning the brass contact points on the back of the sensor with the contact points on the adapter. And securing it in place to ensure good contact between the sensor and the TPS adapter. Then I can take one of my Pyrex samples, place it underneath the sensor, and adjust the height of the adapter so that the sensor lays flush with the top of the sample. And then I'll place my other piece of Pyrex sample on top. Perfect, and then I can just clamp this together to ensure good contact between the samples and the sensor. And I'll just jump back over to the software and let iTPS finish the rest. So now that I have my sensor connected, I can check the resistance to make sure that it's connected well with the adapter. Okay, we got a good resistance check, so then we can move ahead, and this is where we would select the parameters to use for our test. So here we would have to enter the test time in seconds and the power in milliwatts, and this would be something that would be rather challenging to determine depending on the sample that you're testing. So with the iTPS feature, all we have to go is next and add one line in our schedule, select the iTPS feature, and then we don't have to enter the test time or the power. The software is going to optimize it using a single sensing transient. So all we have to enter is the number of tests we want to run and the delay in minutes. So we automatically have it set to 10 minutes, so we'll just leave it as is. And then once we hit start, your schedule is going to begin. It's first going to run iTPS and determine the appropriate test time and power to use for your test, and then go ahead with your measurements. So we've already run the iTPS on these same Pyrex samples here to give you a quick preview of what it looks like. So here we can see that iTPS recommended a test time of 10 seconds and a power of around 40 milliwatts. And with those test times, we got results of about 1.1 watts per meter Kelvin for our Pyrex samples. And that's it. So that's all we have to do for running a measurement and analyzing the data with our iTPS function. It's very user-friendly and easy to use. So if you have any questions, please let us know. Thank you for tuning in.